At first glance this looks like a really complicated question, but is in fact just asking how many molecules of protein there are per adipocyte. So the two things we need to calculate are the number of molecules and how many adipocytes we have present. So let's start by looking at the number of cells, the number of adipocytes. From the text we can see that we've got 1.5 million cells per plate, and they give 2.5 mg of total protein. So this means that 1.5 million cells is equivalent to 2.5 milligrams of protein. Therefore, 2.5 times 10 to the minus 3 grams of protein is equal to 1.5 times 10 to the 6 cells. Now in the experiment we loaded 20 micrograms of protein into the lane of the gel, and this 20 micrograms of protein must have come from the cells. Now 20 micrograms is equivalent to 20 times 10 to the minus 6 grams. So if this protein came from the cells, we're dealing with a fraction of a plate. So if we take the 20 micrograms and divide it by the number of milligrams that a whole plate would give, and multiply that by 1.5 times 10 to the 6, the 1.5 million cells, we find that we get an answer of 12,000 cells. Now let's look at the number of molecules we've got present. We know that the stock protein lane, 1 microliter of the protein stock, gives the equivalent protein of 12,000 cells. So what we need to do is work out how much protein we've got present. To do this, we take the concentration of the protein, 20 nanograms, which is 20 times 10 to the minus 9, and divide it by 1000 because there are 1000 microliters in a mil. This gives us an answer of 20 times 10 to the minus 12 grams. Now, the relationship between mass and molecules is through moles. If we can calculate the number of moles of protein we've got present, we can then, using Avogadro's constant or number, calculate the number of molecules. Now from the text we know that the molecular weight of the protein is 70 kilodaltons, and that is the same as 70,000 grams per mole. So we have the molecular weight. Therefore we can work out the number of moles we've got present. It's just a case of taking the number of grams of the protein present, which is 20 times 10 to the minus 12, and dividing that by 70,000. This will give us an answer of 2.857 times 10 to the minus 16 moles. So in that lane, the band is equivalent to, or it contains, 2.857 times 10 to the minus 16 moles of the protein. To convert this to molecules, we just multiply that by Avogadro's number, which is 6.022 times 10 to the power of 23, and this gives us an answer of 1.72 times 10 to the 8 molecules. Now this 1.72 times 10 to the 8 molecules came from 12,000 cells. Therefore we just need to divide that number by 12,000, and that will give us the number of molecules per adipocyte, which in this case is 14,000.